gravity of a solid of revolution. You know, the centroid we calculated before was for plate sheet. But now, let's consider a solid of revolution. You know, when we have this like y equals fx, and it is now rotated, that's what we mean by solid of revolution. We have calculated the volume before of revolution. Now, when we want to find the centroid, you know that as it has rotated around the x-axis. For y now, we don't need to calculate it. The centroid for y is equal to 0. Unless you are asked that when it is rotated around line y equals to 2, y equals to 3. Except that. But if it is not, the axis, the line that is rotated around, that will be the center or center of gravity along this perpendicular axis. Now, we want to find the center of gravity along the x-axis. You know, like we did for plane shape the other time. That was not rotated, but this one is rotated. And by the time you look at it, you realize that this one now, the volume of this part, let's say this is x, and this place is delta x, and this is y. You understand? So the volume of this part, the volume of that small part, volume of the part is equal to, you can see this one is volume of the part is equal to pi y squared delta x. You understand? And because we're talking about something of tangible size, we can also talk about the density. So, mass of the part is equal to, or let's say weight, mass is equal to rho pi y squared delta x. Where rho is the density. Rho is density. Now, weight of the part is equal to rho pi y squared delta x. You understand? Times g. So we have gotten that. Now, what will be the moment of this small part from this place, about this place? The moment of this, about this place. Moment of the part about y axis will be equal to rho g by y squared x delta x. Do you understand? So if we take it from one part to the other, total moment of the shape now about y axis will be equal to rho g by from x1 to x2 y squared x delta dx. Sorry. So you can see. Now we have gotten the weight before. So total weight now. Total weight will be equal to rho g by y squared dx from x1 to x2. So you can see it has been made simple now. So at the end of the day, you will see what our x is going to be. So the center of gravity along this x-axis is going to be total moment over total weight. This is going to be rho g by x1 x2 x y squared dx over rho g by x1 x2 y squared dx. So you can see now, it has been simplified. So at the end of the day, all you just need to very simple. Our y is simple. Y will be 0 because we rotated it around the x-axis, and the x-axis is 0 along the y-axis. So that is it. It's only x we are calculating now. So that is what we just calculated with this formula. So it's very simple and straightforward. Just like we have done before in calculating what's it called? Mean of square. Root mean, yeah. Just like that. But not really the mean of the square. So this one is different. Is the integration of the y square dx over y square dx. Now let's deal with this example. It says find the position of the center of gravity of the solid formed when the plane figure bounded by the curve x squared plus y squared equals to 16. The x-axis and the ordinates x equals to 1 and x equals 3 rotates about the x-axis. So it's going to be something like this. We have it like this. You understand? So this is 1 and this is 3. So we are now told that this point is now rotated. I mean this shape is now rotated around the x, about the x-axis. So you can see, we are now asked to find, for this shape now, to find the center of gravity. You know, if you look at it, it's just like an equation for a circle. So that's how it works. So we are now going to find this. Automatically, we know that y is equal to 0. So this is y-axis and this is x-axis. So we can see. Now, we want to find x, and that is going to be from 1 to 3. X y squared dx over y squared dx. So it is simple now. Let us find this one now. For me, I prefer to write this one as n over w. That's what I want to write. So here n stands for moment and this one weight. So n now, let's find n. We know that y squared equals to 16 minus x squared. That is y squared. So for this one, for n now, it's going to be 1 3 x into 16 minus x squared. Yes. And that's going to give me 16x minus x cubed. Yes. From 1 to 3. So this gives me 16x squared over 2 minus x raised to the power 4 over 4 from 3 to 1 is 8x squared minus x cubed, x raised to the power 4, sorry, over 4 from 3 to 1. Let me use calculator to calculate this. So n is equal to 44. Now let's find, you can see, after integrating, separating, give me 44. Let's now find w. So from here now, for w, this is the expression for w, which is equal to 16x minus x cubed over 3 from 3 to 1. So just know the process. Every other thing is just integration. That's all. That is all. Now this one, let me quickly use calculator. So when I'm using calculator, I was able to get 23 1 over 3 which is 70 over 3. So w now, I will now substitute it here. It's going to be over 70 over 3, which is 44 times 3 over 70. So let's see what that one gives. So you can see, it gives me 1.89, which means it is 1.89 from this point. So you can see, everything is just for you to know the procedure, how to, do it, and then do your integration. Substitute the figures or the range you are given. That's all.